Number one, plant with round and green seed, or round and green seeds. It's crossed to a true green plant with wrinkled and yellow seeds. Round and yellow seeds are dominant traits. F1 plants were allowed to self-fertilize. What are the following probabilities for the F2 generation? So A, an F2 plant with wrinkled yellow seeds. What did you guys get for that?
I just got 3 out of 16.
That's what I got too.
And you did like the whole, it was like the 3/4 of the, what, round, and 1/4 of the yellow? Or no, wait, wrinkle, 1/4 of the wrinkled and 3/4 of the yellow. You get that?
Yes, 1/4 wrinkled, 1/4 yellow, and then it was 1/4 wrinkled, like, it was like that, which
Yeah.
is, okay, who wants to do B?
Okay. Do you want me to read number 2?
Sure. Yeah.
Okay. Then the next one is the probability that 3 out of the 3 F2 plants with round yellow seed. So for that one, it was the round would be 3/4, yellow 3/4, and you multiply those, and you get 9/16. And then 3 out of the F2 plants is why it's 9/16 times 9/16 times 9/16. And that gives you 0.178 or 17.8.
Okay, I got that one wrong.
Oh yeah.
But that's the right answer is
So, but did you get what I just said?
Did you just use the product rule?
She
The
did, yeah.
multiplication rule. So the traits that it's asking for are the round and the yellow, and that's why it's 3/4 because of those 3/4 is the round, 3/4 is also the yellow, and then you multiply those two, and you get 9/16. But then on top of that, it asks 3 out of the F2 generation. And that's why you raise it to the power of 3, or you multiply 9/16 3 times.
Where was that in any of the videos or any of the like?
I kind of honestly had to like figure it out. It took me a while, and then I was like, wait a minute, like maybe, like I was trying to figure out for the longest time because I did get it wrong the first time I did it.
Mm-hmm.
So when I looked at the key and it said raised to the 3, that's how I figured out that the 3 is the number of like progeny that it's asking about.
Yeah. I was just super annoyed because I like watched all the videos and like went through the PowerPoints
Yeah,
and
it wasn't in anything.
yeah. And I was like, how am I getting these wrong? Because I got the same things, like I was getting like the same,
Yeah.
but not raised to the third.
Numbers.
Yeah.
Yeah.
So it was like I got the first part of it, but then the second part, like all those ones that are raised to a certain power, like I didn't get any of them right because I didn't know that that was a thing.
Uh-huh.
So for because I still don't completely understand. So we're looking for round yellow seeds. So I picked out all of the alleles that would get like allele combinations that would give us round yellow seeds, and there are there's 4 combinations. Is that what you did? Am I on the right track at all?
So like I did it, I just used the fork line method. I'm so sorry, but my handwriting is like terrible. I don't know if you can see what I wrote. Can you see like that part?
Yeah.
Okay, so then I took the 3/4 of round and the 3/4 of the yellow, because those are the only traits that it's asking about. And it doesn't matter in what combination it's going to be in because it will show those traits. And then multiply those two.
So you multiply them? So
Uh-huh.
it's 9 out of 16.
Yeah. But then because they ask for the 3 of the progeny, so like we don't know how many children are in the F2 generation, but it does ask for 3. So if they ask for 3 or 4 or whatever, you would raise it to that power.
Okay, let me just double check something real quick to make sure
Okay.
I at least do something right. Um,
Because I think there's like another question very much like it.
yeah.
Where else? Oh, it's in part 2. When we get to part 2, it kind of does the same thing.
Okay, so you add those. Let me just write down how you did that real quick.
Uh-huh.
Also, you guys, I was super confused by the factorial stuff.
The what stuff?
Factorial things. I don't like
Oh,
that.
the factorial.
That like in the instructor notes, there's like the binomial expansion equation with like a bunch of factorials in it, and I was like, okay.
Yeah, for one of the things, I didn't notice that one of them had an exclamation point. Like, you know how it was like 7 exclamation point over
Yeah.
3 exclamation point and then the parentheses? After the parentheses, I didn't know there was another exclamation point, and so I kept getting it wrong every time, and I was really frustrated.
Yeah. Well, because like in the video, the guy forgets to put the exclamation point. And then he continues the video and he's like, oh, my equation's wrong. So he has to go back and say that he forgot the exclamation point. So I think that's probably what happened. Because with the first time the guy writes the equation in the video, he forgets that exclamation point.
Which video was that too?
Um,
Because I didn't. Was that the one she sent out? Because I went through all the other ones
yeah, that was the one that she sent out, the binomial one.
that she forgot or whatever.
Yeah.
That's the only one that I didn't get around to watching. But like I watched all the other ones and I was like, where is this about factorials? Because I haven't done that stuff since I was like 16. Like a
So,
long.
like, if it says like, well, maybe we'll get there, but if it says 6 factorial, then it's like 1 times 2 times 3 times 4 times 5 times 6.
I just feel like that's so much.
Yeah.
I don't have
It's a lot for one
I
stupid
don't have like
problem.
yeah, I don't have a calculator with like a factorial button on it. Like I don't have like a graphing calculator. That's usually what they're on. But
Yeah.
I was so frustrated with this whole lesson. Like
Yeah, that's what But I'm nervous about this test. Has anybody already taken it?
I haven't.
I haven't done the multi-choice part. I've done
How many questions are on it?
55, I think.
And it is a mix of like the scan-in. Oh yeah, it is on the scan-in kind and then the multiple choice one.
Wait, what?
Like some that you have to like scan or take pictures of, and then some that you. Like,
Yeah, there's part A and part B. Part B is the scanning one, part A is the multiple choice. But is the multiple choice like all 55, or is it like 55 both part A and B?
I don't know.
I think. Alright, let me just look again.
But double checking not to be paranoid. It is today, right?
Yeah.
Okay.
At midnight, right?
So the short answers part is 20 points.
Okay.
I'm super stressed about this. I'm not gonna lie.
Me too.
Yeah, I feel like I don't know anything in this class, but whatever.
I totally thought the test was next week, and so I looked at it, and then I was like, freak!
That's the worst.
So yeah.
You can do it. We got this.
Yeah.
Yay!
I had an ichthyology test yesterday too, and so I spent, like all week studying for ichthyology, and then this happened. And I was like,
Yeah.
Okay. C.
Okay.
Let's do C.
Are we good? Or
Yeah.
ready?
Yeah, I wrote
Okay.
down how you got that. I still don't fully understand how it's different than what I did, but that's okay. I'll have to go over that again.
Mhm.
The
Um,
most I just hated was the differentiating between the sum and the product rule, I think. Because for D, it was like, I totally thought it was doing it the product way, but instead it was doing it the sum way, and so I was like, oh, okay.
Yeah, that one I struggled with that one. Yeah.
so what did you guys
That's
get for C?
62.5%.
Yeah. Mhm.
I don't know. I didn't have a problem doing stuff like with the product thing
Mm-hmm.
according to like how the video did it, but for every trait, I always have to draw a Punnett square. Even if I like know or I think I know, I just like have to draw it out because and then count up the numbers and then multiply it because otherwise it's too confusing. Like I can't keep it straight.
Mhm.
Me too.
Yeah.
So everybody got that one, right?
Yeah, I think.
And then D, um,
That's the one that will not have round yellow seeds.
yeah, so
So,
the question was a bit like kind of threw me off because it says not have round yellow seeds
Yeah.
instead of having
mm-hmm.
it.
So then it's just the probabilities of all the other ones
Together.
added up.
Oh,
Well,
that
that's what I thought. And when I did the equation, it was completely wrong.
Really?
Yeah, so
Did you multiply them or did you add them?
I added them. So like, because if it's not, then if you were to reword them, then that means would have um, wrinkled green seeds, right?
No, it would have either wrinkled green, round green, or wrinkled yellow.
Oh, okay.
Yeah.
That's what it
All
was.
the other possibilities added up that it wouldn't be that one.
Okay, I need to write that down. So the 3 over 16 is like, let's see. Where does the 3 over 16 come from?
the three.
The first 3 over 16 plus 3 over 16 plus 1 over 7.
Um,
So,
the first one should be. Wait, hold on. Because round and yellow are dominant, and green and wrinkled are recessive. And then it would be the round green and the yellow wrinkled would be the 3/16.
okay.
And then the recessive one with the 1/16 would be the wrinkled green. And you add all those up together, and then like, you get your
That makes so much more sense now.
yeah, because you have to like take all the possibilities into account.
Okay.
Are we all good on that one then?
I'm good on it.
Okay, I'll read number 2, and we can talk about this one. I just wrote all these because of whatever pow, the third power, whatever that what is that called? Exponents. I can't think of words today. Okay, so number 2. Suppose Mendel crossed a true breeding tall plant with purple flowers to a true breeding dwarf plant with white flowers. Tall and purple are dominant, white and dwarf are recessive. The F1 generation is allowed to self-fertilize and produce F2 plants. But A, what's the probability that the first 4 progeny plants produced by the cross are tall and purple? And I did it wrong at first, but then when I went back over and did it again, I got the 9/16 part right, but it was to the 4th power because I didn't realize it was the first 4. And that question confused me because when it said the first 4 progeny plants, Or I was thinking that they were talking about the F1 generation, and I was like, all of F1 is going to be tall and purple.
Oh.
So I was like, wait a second, and then I was like, oh, never mind. They're talking about the progeny of the F1. So.
Yeah. So this is just like the one that was on the last question, where it's being raised to the 4 because it's asking about the first 4 children.
Yeah.
Yeah.
And I just did that with that product rule or whatever it was.
Yeah.
Anyways, I put in my notebook. I don't actually have it in front of me.
Hi, sorry for being late.
We're
Jennifer.
only on number 2, so
Huh?
we're only on number 2. We're on B for number 2.
Okay.
If everybody's good with A, we're on B. Okay. So then, yeah, the second part of that, what's the probability that the first 4 offspring are either tall with white flowers or dwarf with white flowers?
And then you get 3/16 tall with white flowers, 1/16 dwarf with white flowers, and then this is the part where I got it wrong, was I put them in brackets. I added them together, put them in brackets and raised it to 4, but apparently you're supposed to put 3/16 raised to 4 plus 1/16 raised to 4.
Yeah. And I guess that makes sense, but I feel like either way, like, would make sense, but one is not
Yeah.
right. But that's so frustrating.
Yeah, I can't even say anything on this one. I'm getting all of them wrong, but I think I understand what I'm doing wrong. I just have to go back and recheck.
Yeah, and like look at the answer key because that'll tell you like it'll show you how to do them and like give you a better idea since the notes don't have that stuff in there.
Yeah.
Yeah, sister Mayo, whatever her last name is. She
I know.
also.
Yeah. I always want to say Mario too, and I always read it like Jaime instead of Jamie. I don't know if it's supposed to be Jamie, but I'm like Jaime.
Anyhow, no, but within an email that she posted in like the announcement, she also posted her own like work of how she did her problems, and she did it for numbers 1, 2, 3, and 5. And so for those, like you can see her scratch work to see how she did it too.
Oh, okay.
For number 5, it's not that like descriptive, but for the other ones, it semi makes sense. So if that helps.
Okay. Yep.
Down to C. What's the probability that if 7 F2 plants are produced, 3 are tall with white flowers and 4 are dwarf with white flowers?
And that's the way I use the binomial equation.
Mhm.
Yeah, I hate that, and I'm probably, if we have any of those on the test, I probably won't get them right because I don't have a calculator that does that. So
how do you know when to use the binomial?
You know when to use it when it asks, let's see, what is probably?
in the instruction notes,
Asking for a probability of the offspring that have already been produced. So it already gives you like a total number of the offspring, so it's 7 of them, and then it'll ask something of the 7, how many are this and how many.
Like out of.
Yeah.
Like kind of thing.
yeah.
So
Why does it give 2 different answers though?
What do you mean 2 different answers?
one of them is in
that's-
percentage.
One's decimal and the other one's percentage, yeah.
Oh, okay.
So for this one, so the 7 factorial, that's the 7 children. And then the 3 and the 4 represent the different proportions of children. So like there's the 3 that are tall with white flowers, and then there's the 4 dwarf with white flowers, I guess? No. The 4 is the 7 minus the 3. So, I don't know. Maybe this helps.
Okay, so you do, for that, you do like 1 times 2 times 3 times 4 times 5 times 6 times 7.
Yeah. And honestly, I don't know where that is on my calculator, like the factorial theme, so I just did it like that.
Okay.
So for the 7, it's
And it's divided by 3 factorial times 4 factorial.
Yep.
no, divided by 3 factorial, and then the other one is the total again, the 7 minus the 3, and that's how you get the 4. And that's a factorial. I don't even know if you
I
can.
need to look.
Do we have to memorize? That sounds like a stupid question, but do we have to memorize
He actually
that?
gives us the equation on one of the things. I don't know, can you see anything I wrote?
Yeah.
Yeah.
Do we have to memorize the equation?
No, I don't think so. Let me see. Where's
Now,
the...
did you just like start the test and come back to it? Like save it?
I have no idea.
So I was
That's
like,
why I haven't started it, because I'm too scared to start it and find out, oh, now I have to finish it.
yeah, right? Because I don't want to like risk not having it saved in case something happens.
No, for the part that she wants you to answer with the binomial, she gives you the equation
Okay.
Okay.
on the on the on the write-on part. I don't know about the multiple choice part, but on the write-on part, she gives you the equation. Okay. So, I don't know if I can.
What are we on now?
Okay, so we got as far as there, but then the equation continues, and it's the 3 out of 16, that's the 3, what was that in the question?
That's for the tall with white flowers, right?
So 3 out of 16 tall with white flowers, and the 1 out of 16 is the
Dwarf with white.
dwarf with white flowers. Okay, and then it's raised to 3 again for the 3 out of 16. And for the 1 out of 16, it's raised to 7 minus the 3. Okay. And then you just calculate that, whatever values you have from there on.
That gives you, that's the probability of both of those things, not just the tall with white flowers.
Yeah. Mm-hmm.
That's so weird. Why, I don't understand why why you wouldn't do like a 4 dwarf with
The
white
other one.
uh, why it's all based around the tall with white flowers and why there's not really anything about the dwarf with white flowers.
Well, it does involve the dwarf with white flowers. It's just put into the equation because the dwarf with white is the representation of the 4 that we're trying to get. So that's where the 4 factorial comes in. And then after that equation of the 316 raised to the 3rd power, you have the 1/16, which is the dwarf with white flower, raised to 7 minus 3, which is the leftover 4 of the dwarf white flower. So it's in there. It's just not like as prevalent, I guess, because we're just trying. We just want 3 first, I guess. Oh, not first in order, but like just that's what the problem stated first. So that's what I'm assuming. That's why there was the 3 factorial first and then the other one. I'm not sure if it would have worked the other way. I'm probably assuming yes, because no matter what, 7 minus 3 or 7 minus 4, you still will get either 3 or 4. And if that's the other one that you're trying to get, then it should still be the same.
Oh, like no matter how you did the equation, like no matter which one you put first, it would still be.
It should still be. I mean, it makes sense if it is, because if you do 4 factorial and then 7 minus 4, then you'll still get 4 factorial times 3 factorial. So it'll still be the same.
Okay, that makes more sense.
So either way, it should be all right.
Mm-hmm.
I feel you.
Okay.
Okay,
Are
so
we good with that question?
I think so. So for D, it just listed a whole bunch of progeny, and I totally didn't realize that we had to multiply them all.
Well, it doesn't say anything. It just makes the statement.
Yeah, so that's why I was like, okay, cool. I'm gonna just write this. The end. And I was so confused.
yeah, it really doesn't, huh? That's so
Yeah, it just says Here's some information.
Figure out what to do with this.
Just guess.
Guess what you want me to do with it?
I hope that the test isn't like this.
I
Yeah.
know.
I am not a good guesser. I can't read minds.
The reason why I found out that you should probably multiply it though is because the next topic after the binomial one is the one with when the children are not put in order or proportions.
Oh, yeah.
So the question before, you can only use the binomial equation if it doesn't state like that the children or the offspring are in certain order. So if it says, oh, first there were the 3 white flower, and then next there were whatever was next. So if it states in order, then you can't use the binomial expansion equation.
Yeah.
Hmm.
Okay, that makes sense.
So then I was like, maybe that's what it's asking for now.
Mhm.
I just
That
took
was like the
a shot of the
PowerPoint too, because I don't see that in the instructor notes.
It's only on the video.
Oh, okay.
She
Which
sent.
video is that? Oh, is that the binomial, the one I didn't watch?
Yeah. But like I didn't realize that until later, because that was the one where she sent something saying that I got that one wrong.
Hmm.
And
So if it's in an order, you don't use the binomial.
yeah, so like if it talks about children and it says, oh, first the parents had 3 boys and then they had 3 girls, or 2 girls and then 3 boys. So once you see that it's stating that it occurred in a certain order, then that's how you know that the binomial expansion equation doesn't apply.
Okay.
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 So, and if it doesn't apply, then all you do is multiply all the outcomes, like in D.
Alrighty.
Hmm.
Sounds good. Okay.
Number 3.
Alright.
I'm gonna find my number 3. I did it on the paper.
I'll just go ahead and read it.
Okay.
I have it in front of me. A cross was made between 2 true breeding strains of plants that are agriculturally important. One strain was resistant but herbicide sensitive. The other strain was sensitive but herbicide resistant. A plant breeder crossed the 2 plants and then allowed the F1 generation to self-fertilize. The following data were obtained. F1 generation, all offspring are disease sensitive and herbicide resistant, of course. And then F2, 157 disease sensitive, herbicide resistant, 57 disease sensitive, herbicide resistant. What? Oh.
Yeah, you got it.
My gosh, I hate reading all these. And then 54 and then 20. I'm just going to say that. So A, formulate a null hypothesis that you think is consistent with the observed data.
Okay.
I definitely got this all wrong.
Jennifer, how could you?
Oh,
After all our chi-squared stuff that we did in April. Oh gosh.
Are we gonna
I
be
don't remember
given the
that.
chart?
What?
Are we gonna be given the chi-squared chart?
Yeah.
Audio, because
On
nobody
the write-on
tries
portion.
a statistics book. Like, that's not cool.
And when do we reject the null? I always forget that.
I don't even understand how to do the fail reject.
It's when rejecting it is when your probability is less than 0.05, I think. Or when you get a really high number is when you reject it.
So when it's
Wait,
At least that's what that little on the PowerPoint it had it like that.
so when the p is less than 0.05.
Then you accept your null.
No.
Then you accept it?
Mhm. Yeah.
You want your P to be really, really low.
Yeah.
Okay. Got it.
Critical. Oh, I can never remember what's the critical value. Isn't there like a critical value? Or is that it? What am I thinking of?
Yeah, the critical value is the 0.05.
Oh, okay, that's the comparison.
Yeah.
called like an F crit or something?
I think that might be on a different test.
Oh, is it? And
It sounds like it.
now I'm like pulling up my old biostat stuff from last semester.
I don't even have it, so.
I did good in that class, so hopefully, hopefully I can remember stuff. Yeah.
If biostats was all this probability crap, so I was like, ah.
Okay. I haven't done biostats in a long time, so.
Me neither. It's been like 3 years.
Okay. Well then, let's see. I'm like reading through the things here.
Okay, so sorry for sounding like a broken whatever that English saying is. Record. That's
Record.
So it's less than, you accept, or aka fail to reject, and then if it's greater than 0.05, you reject, right?
Yeah.
Okay. So for this one, do we use our chi-square value to determine that?
Yeah, so you find the chi-square, you compare it to the chi-square value, because your chi-square value, it'll tell you whether you fail or you reject it.
Okay. Does that mean we rejected for this one? I don't know if I totally missed that if we said that.
No, we fail to reject it
Oh,
because the chi-square value comes out as 0.543, which is pretty much.
But that's because, so you don't use the, you don't want it, you're not looking at the chi-squared value when you're saying you want it to be low. You use the chart and the chi-squared value to find the p, and that's the value that you want to be lower than 0.05.
Okay, so from the chi-square value to the value that we interpret, how do you do that? Because on the PowerPoint, it just skipped from 1.05 all the way to 0.861. Is it literally just that?
I don't remember. Hold on.
I know that you need the degrees of freedom to also find it.
Oh, JK. I know what you're talking about. Never mind. JK.
I still don't know.
I need to go back and watch those videos again. Just like remind myself how to do it.
I just wish on these keys that it shows like how you get from step to step, not just the answers.
Yeah, that would be really
I did something wrong, but I just don't know where.
So for the first one, the part A, our null hypothesis, I don't like this. I don't like how this is done. Because usually a null hypothesis, you say like...
So the way that I worded it, because it's how it was worded in the notes, was you have to say which trait is dominant over the other trait. So like for this I said the disease-sensitive trait is dominant to the disease-resistant trait, and you say the herbicide-resistant trait is dominant to the herbicide-sensitive trait.
Oh, okay.
You have to say, and the cross follows Mendel's law. I think that you have to say that third part.
Yeah. So, like, I think the reason why Sister Maya said she put in her null hypothesis, and she said it's something about the law of segregation and the law of independent assortment. And that's why she showed all the other stuff. Like, you know how she separated the traits, and then she did the F1 generation being having the heterozygous traits. It was all to prove why she chose that hypothesis, I guess.
Okay.
Because it says there are true breeding parents, so that means if they're both true breeding, that means one of them is going to have all the recessive traits and one of them is going to have all the dominant traits, which means their kids will have will all be heterozygous for the trait. And that's why she said that the traits follow the law of independent assortment and segregation.
So that 75% of them are from the F2 are going to be
and then she shows that 9-3 to 3-1 ratio. So it's all pretty much just to prove that the law of segregation and independent assortment are followed.
Okay.
Yeah. Because, like, she could have just stated her null hypothesis, I guess. But then when I was trying to figure out why did she give all that other information where she shows, like, the H's, the D's, and all that stuff.
Mm-hmm.
And then I was like, oh, okay, I get it now. Like, she's trying to show us where she got her null hypothesis.
Okay.
Okay.
So then we get our chi-square value of 0.543. Like when you just do that, follow that equation, do that math.
Mm-hmm.
And then so you find, okay, so you have your degrees of freedom, which, how many degrees of freedom is it?
It's 3, I think, because from how I got it, it was like we had 4 different like little mini things, and so from 4, the degree of freedom equation would be n minus 1, and so from that 4 minus 1 would be 3, and so from the degree of freedom chart we go to 3, and then we somehow go swoop, and then from there
Okay.
I can't talk anymore. I don't know.
Okay.
I think, right?
I think that makes sense to me. I need to go back and watch the video next time. Just
Yeah.
Is the chi-square value within the chart, or is it on top, like the bar?
I don't remember.
I think that's within the chart.
Okay. So we just estimate in between that range?
I think so.
Okay, because none of those values match 0.54, but there's like 0.115 and 0.352 and 1.05. So if it's like that, then is that it?
Yeah, it's like within the range.
Okay. Then, okay. I get it then.
Cool.
I don't like it, but I get it now.
Just should we do the next one?
Sure.
Okay. I might need help with these. I did not do well on this section at all. At all. I'm kind of scared.
On number 4?
Yeah. Well, I didn't do well on anything, I feel like, this time around. Last time I think I got it, but. So, number 4, it gives us a chart. And I'm a little bit confused about the diagonal lines. What the heck does that mean?
The diagonal line, it just means that you just assume that there was a mother and a father, but because the mother was just plain, you just assume that the father is the only one you care about, and so it's going from father to son.
Nope. It doesn't make sense because it has an affected mother, and then it has diagonal lines for male and female children.
Wait,
You know what I'm saying?
wait. Are you looking at 4A?
4A.
Okay, are you looking at 1 or 2? Like Roman numeral 1 or Roman numeral 2?
Roman numeral 4 and 5.
Like the very
Diagonal
bottom.
Okay, from that, it's just saying that from the Roman numeral 3, you had we're just gonna assume it's a father, and the father mated with a non-affected mother, and together the couple had 4 girls. My bad, 4 girls. And then from that 4 girls, they had you have 3 affected daughters and 1 unaffected daughter. The only way you can have an unaffected daughter is if somehow you have, because of the fact that in generation 3 you're assuming that the father is affected, but you're assuming that the mother is not, since it's because if the mother was affected, it would show in the graph. So in this one, in generation 1, 2, 3, 4, you focus on the 3 affected daughters, and then from there you try to decipher. Now, because of the fact that it's not skipped, you can assume that it can either be autosomal dominant, Y-linked inheritance, or X-linked dominant. because there's no skips in the generation. However, the Y-linked inheritance is only from father to son. And so because this in generation 3 to 4, because there was a father to a daughter affection, you can cross out the option for Y-linked because that's not an option anymore since it's father to daughter. Now the only option then you have then is autosomal dominant or X-linked dominant. And autosomal dominant, you would just assume like a normal thing, like it would just be a normal cross. So like for this one, if we were to take the generation 3 father, we would assume that in order to have a non-affected daughter, the generation 3 father would have to be like big D, little d, for instance. But the mother would be like little d, and so if you cross it together, you would have
Heterozygous.
you would have heterozygous, but at the same time, if you have a little d, then that's how you have your unaffected daughter.
Oh, I see. So then the dad on generation 3
Mm-hmm.
is heterozygous, and the mom was unaffected.
Yes. So every time, like in this chart specifically, usually it's not like this, but in this chart specifically, because they didn't mention like for generation 1, 2, and 3, like because they didn't have a circle next to them, you just assume that it's an unaffected like spouse. So.
Yeah. So then it can't be X-linked because because you've got that unaffected daughter.
Wait, which one are we talking about? X-linked recessive or X-linked dominant?
Oh, I don't know. Wait.
Because there's 2 X-linked traits, and it's really annoying.
Wait, then yeah, how would you know which one it was?
Okay, X-linked recessive, it skips generations, and so it will go like, you would have one generation and it'll have an affected, and then the next one, it skips, and no one in that line would. But because this one, if you notice in 1, 2, 3, all the way to 5, every single generation has it, that would mean that it can't be an X-linked recessive. So your only options would be the autosomal dominant, Y-linked inheritance, or X-linked dominance. But because there's a daughter, it can't be X-linked inheritance, so you have either autosomal dominant or X-linked dominant. But it can't be X-linked dominant because if it was, then there wouldn't be a carrier of sorts.
Yeah.
And so in that case, the last 4th daughter would have had it, but because she didn't, that's how you know it's autosomal dominant.
Okay.
Oh my goodness.
That was
So I'm gonna fail this
I
test.
have no idea how helpful that was actually.
Wait, was that helpful or did I just make things worse? I'm so sorry.
I know made total sense, but I don't know if I could think through that on my own.
Yeah.
That was awesome.
Yeah, she used like this whole process of deduction. I'm like, how did you do that?
Basically, I just made like a chart thing. So like out of the
Give me the chart.
no, because like out of the 5 options, I just counted which one was a skipping one and which one wasn't. And so from there, you just did
which
process
one
of
is the
elimination.
skipping one?
No, you only have 2 skipping ones, and there's autosomal recessive and X-linked recessive. There are only 2 recessive ones.
Okay.
Huh.
So the
And it
recessive
makes
ones
sense because.
skip, and the recessive ones skip a generation.
Yeah, the recessive ones skip a generation because if you think about it, when you think of autosomal recessive, for instance, when you have to cross it together, you only have the option of little d. Now the chances of that happening, like meet another person, because you can meet 3 other spouses with the option of big D, little d, or little d. But you only have 1/3 chance of meeting another little d. And so the other 2 options, if that person goes with those other 2, then it would have to skip a generation because then their children would have a dominant allele, and so it would skip that whole generation. However, if they were, because in the end they would be heterozygous, if they meet another person who is heterozygous or recessive, that's 2/3 of a chance that they will have to pass that gene, and you would have a little d, and so therefore the allele will pop up again in the next generation. So that's why it keeps skipping.
Okay.
But the other ones, because it's dominant and because of the X X sex chromosome, because of the fact that they're so, how do I put it, like there's a greater chance of happening. That's why it doesn't skip at all. Out of all the questions, this was the only one I was okay with.
I'm just done. Like, I can't.
It's just so much information.
Okay, let's go to B. You can explain B to us.
Okay. Okay,
I guess
so
the only input
I got that one right. Okay, so this. So on B, it can't be Y-linked because of the first mom. Doesn't skip any generations, so it can't be any kind of recessive. And it can't be autosomal dominant because
You're on the right track. Go on.
well, wouldn't it be a higher percentage affected if it was autosomal dominant?
Well, this one, when it comes to these two options, this is when like I kind of mentally try to track it. And so if we were to assume this was autosomal dominant, like say the mom is, the dad has to be little d, and mom in the first generation, we can either assume to be big D, or big D, little d. Now, if we look at the children, there's we have a half and half. And so, where am I going with this sentence? I totally lost my train of thought. Okay, and so we can't assume that the mom is a big D, because if it was, then all of these would be affected, because the autosomal dominant would mean that if they were a big D, little d, they would still have that gene. And so because of that, you can, if we were to assume this was autosomal dominant, we would have to assume that the mother was a big D, little d. And so from then on, the gene, if we were to assume that this was the case, would be that the big D, little d is the trait from now on. And so in the second generation, so if we were to assume that and keep going, and that means that from the big D, little d, in the second generation for the left side, the little square, the father, mates with another little d, and so now you have all the daughters, and none of the sons affected. And then from here,
can't, because he's not giving an X anyways. Those boys. Wait, hold on. Wait.
Hold on.
Makes sense to me.
Okay, but if you looked at X-linked dominant, however, I'm trying to explain this without confusing, and I don't think I'm doing very well.
Oh, keep going. Keep going for why it's not autosomal dominant.
Okay. So for on the PowerPoint, it says that both males and females can be affected, which is true. We both have that. However, I'm looking for the answer. Hold on. Not answer key, but like the answer in the PowerPoint. I'm trying to find it. Okay.
I have a
This is
question.
awkward silence. I'm sorry.
I don't know.
Yes, sorry.
Okay. So when you look at any of the males who are affected, and you notice that their daughters are always affected, does that mean that that's how you know for sure that it's, I don't know, how would you say this? Oh, never mind. I think I'm just going to confuse everybody even more. I'm going to stop right there.
Okay. For X-linked dominant on the PowerPoint, it also says that affected females, all daughters of affected fathers are affected. And so on the second generation, there's the father, and when we looked at his children, all 3 of his daughters were affected, but none of his sons were. Now, this is the case because as we know, when you have a daughter, you bring both of the X's, one from the mom and one from the dad, there. And because of the fact that the father is affected, he has to bring his one X over, and the mom has to bring her X over. But because the mom's not affected, she's okay. Now, usually, if this was an X-linked recessive, we would just consider this a carrier, because then the daughter would have X and then a notation thing, whatever you want to call it, and then another X plain. However, because this is an X-linked dominant, and because we already assumed that it's not X-linked recessive, because this is an X-linked dominant, just one on an X chromosome is enough to make it affected. And so this one, because the sons already got the clean X chromosome from the mom who's not affected, that's why they're totally like, hey, look, I don't have a disease. But the other three, because they brought it both from mom and dad, and because the dad's already affected, just one bad chromosome or X chromosome was able to make all the daughters affected. So that's why there's all the lines on there.
I got you. That makes sense.
Okay. I can't explain any more as to why it's not autosomal dominant, I think, at the moment, only because I'm losing my train of thought. But to explain that there were more reasons as to why it was X-linked, I can't explain that. Because not only was there that, but for the most part, it also says on the PowerPoint, all sons of affected fathers are usually unaffected. And so when we look at it, no matter which father we look at, whether it's Gen 2 or Gen 3, the fathers, all the sons are always unaffected.
Mm-hmm.
Oh, okay.
I got you.
So that's the only way I can explain that part, as to why that one's more of an answer than the other one, at least. So, yeah, I'm gonna stop now.
Okay. Let's do part C then.
Okay.
Ugh. Us.
I got this one right too, but I don't know why.
I don't know either.
What? So.
So this one, it's just because the first generation's a skip, you can either assume it's autosomal dominant or, oh, my bad, autosomal recessive or X-linked recessive.
One.
Yeah, and then because only the males are effective, you can assume it's X-linked recessive. It's kind of like the color blindness because of the fact that the males only have one X chromosome. That's why they're the only ones affected. But in this one, the girls, they can be carriers, and so that's why they're not shown as affected.
Oh, okay. That makes sense.
Sweet.
Okay.
So then number 4, or B, whatever.
It skips generations, so it has to be recessive.
Mm-hmm.
And there's both kinds. There's men and women that are affected every now and then, so...
So not X-linked recessive. If it's like that.
That's it.
Sweet. That one's easy.
Ta-da!
That's not too bad. That's hard, but it's not too bad.
I guess once you know the trick, like Shannon does.
No. Do you have like that written down somewhere you can pass it along? That was a joke. Yeah.
I was really confused. I didn't know how to respond to that, so I just answered with awkward silence.
Oh,
Okay. Number 5, guys. Yay. Okay.
Okay. Well,
Don't laugh at me.
Okay, I'm gonna read number 5. So we can...
oh, there's a. Oh crap! Where did that go? I gotta pull it up on my computer. I guess I lost number 5.
Oh no. Okay, I'm just gonna start reading it.
Oh no, I did this. Okay.
So, at the beginning of the 20th century, Lucien, how do you say that? Quinault?
Yeah, no one cares.
It's French.
Okay.
So.
No one cares about French people.
Hey, you know what? Watch it, Shannon. Should you be dissing on that? It's the only other language I ever learned in my life. So.
Sorry.
Anyways, I don't know how to pronounce that because I can't tell what that C is supposed to be. Anyways, so this dude was studying the genetic basis of yellow coat color in mice. He carried out a number of crosses between 2 yellow mice and obtained what he thought was a 3-to-1 ratio of yellow to gray mice in the progeny. Following tables give his actual results along with the results of a much larger series of crosses carried out by 2 other investigators. Okay.
So, this one I have no idea what to do. Someone help me, please.
Yeah.
Because I thought we started this one out just like number 3, but then it wasn't. And then I got really confused.
It looks like it, especially like I'm looking at the key right now, and it's got all the null hypothesis and
Jennifer, remember when we
everything.
did this exact thing?
Did?
Remember, we compared our muscle population to those other girls' muscle populations. And remember how it took like an hour and a half for Dr. Holyoke to explain that to us?
Holy crap!
Okay, so we should know how to do this, but let's be real, I don't remember.
I don't remember. All I remember is taking lots and lots of pictures and counting lots and lots of times.
Yeah, right.
Maybe we could look at how she did it in the. Oh, she actually didn't even give us much.
No, she really didn't. That's why I was even more confused. Because I thought that because it was like 2/3, and I thought instead of doing like number 3, we did like 9 and 16, 3 16, and like 1 16, like to start off and all that. So I thought it was like that, but except in 2/3 and 1/3. But then when I multiplied it by like the total, it wasn't her like what she wrote out, and then no matter what I did, it did not end pretty, and so I was really confused, and so I gave up and just decided to ask you guys.
Oh, man.
I can't.
That wasn't the smartest idea. I have no idea what I'm talking about this time. Hold on a minute. Because the thing is, I did all of that wrong on number 3. Like, I did it completely wrong, so
Yeah.
I can't.
Okay, so it says that the chi-square value for this one is 1.188 with 1 degree of freedom. So I get why it's 1 degree of freedom, because you're comparing study 1 to study 2.
Yeah.
Yeah. But then everything else made no sense.
I can't remember what we. I want my notes from Oregon in front of me that I know. I can't remember what we did.
I'm just hoping on the test it's like, I don't know. I don't want number 3 to happen either, but if we have to have a problem that's like that, I hope it's only like number 3 and nothing like number 5, because I don't understand number 5.
Yeah.
Yeah, I got it wrong.
I think what you're saying. How do you do this? Oh crap! Hold on. Like, no. I'm trying this thing. So we're trying to compare. The first guy's results.
Can you guys tell where she got her value in 5A?
What?
Can you tell where she was able to get those values that she got in 5A? Because I can't tell.
I have no idea.
So I can see where she got the 263. I just can't tell where she got the 272.25.
Okay, wait, where is this stuff posted at?
She sent it in an email of her working out, like the stuff she wrote down when she was working out number 5.
Okay. Let me see if I can find it.
Dude. Like, how did she get that expected value?
Wait, and when did she send that out?
On Thursday?
Oh, I see. I found it. Gosh, I'm so screwed.
Mm,
Wait, so does that mean no one knows what to do with number 5?
I have no idea.
That couldn't make sense. On part A, on part A, if you look, it says the chi-squared value is 1.188. But then on her work, she has different. She has 1.25.
oh. Uh-oh.
Oh boy.
Let me check if she might have sent an email later saying something. Not expecting.
Oh. 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 I see what she did on part A. Like I know how she got the expected value.
How did she get it?
So if you're expecting it to be a 3-to-1 ratio,
Uh-huh.
it's the total times 0.75 or something, I think. Let me see.
Total? Like the 363?
Hold on. Let me try and do the math really fast. So 2
Oh, it is.
plus 100 equals that times 0.75. Yeah. Because it's a 3-to-1 ratio, so you're expecting 75% of them, of the 75% of the total, to fit into that first part. And then, but he only observed 263. So you take your observed minus expected over expected and square it. You do the same thing on the other side. So 363 times 0.25 should be 90.75. Yeah.
Okay.
The chi-square value should be 1.25 or whatever it is that she got if you do all the math correctly. I don't think the answer key is right.
Yeah, I remember she said something about like something not being right, but I thought that was the quiz and the test. Because I know that for the test, she said that the matching was keyed incorrectly, and so we'll get a lower score than it should be, but it's actually higher, unless we got everything incorrect. And then for the quiz, it was something else incorrect. But that's like the lesson 3 quiz. And then the last one is I didn't know if the homework was keyed incorrectly.
I don't know either. But I
What
know
you said made a lot of sense.
that's how she got it. So you just have to calculate your expected value sometimes. If you don't already know what it is, you can just calculate it based on what you got.
Okay.
And then, okay, so that makes sense then. So then you just do the math, you just plug it in, and it says that you'd fail to reject the null if you have 1 degree of freedom.
Mhm.
Oh. Okay. And then B, using a chi-square test, determine whether their results are significant. from the 3 to 1. So you do the same thing, but you do the second study
Mm-hmm.
with that.
And then the C is just the both combined and that's it, and it's the same exact thing. Okay.
Yeah.
Okay.
And then D, provide a hypothesis that it's
Okay.
They're all pretty much worked out, pretty much the same. Just C's are different. The first two are kind of the same, the way they're worked out, but C is different.
Is C different?
Well, I think. Oh, actually, no, not C. Which one?
D?
They're all done pretty much the same.
Yeah, they're done the same. Never mind.
Yeah. Okay. Well, those make sense then to me. I just need to
Okay.
get back with the video.
Yeah, you just kind of need to do the working out. I think the only way to remember it is to do the working out.
Yeah.
Which is gonna suck.
I know.
Do you guys know how long this test is gonna take to take?
She said in her random announcement, so for some people it'll take an hour, and for some other people it'll take 4 hours.
Holy crap. I'll be
Yeah,
4
me.
hours.
And then we have all that other
I'm
stuff.
both people, so I'll probably take 5.
That means I gotta start now. Like,
I still gotta go to the store tonight. I have one more. I have to get a couple of things before.
I still gotta finish the homework for tonight.
Yeah, I need to.
Quiz. We have a quiz. Okay. I'm good. I'm good if you guys are good. I gotta.
Okay, yeah. Are we good?
Yeah.
Okay, who's gonna post a thing on the
I'll post
discussion
it.
board? Okay, thank you.
Thank you so much.
Bye, you guys. Good luck.
Bye.
Good luck to y'all. Hope that you don't die.
Night.
Good night.
Yay, we're all gonna die. Okay, bye.